All right, hi everybody, this is Mrs. Resch, and I'm going to be teaching today. So we're going to start with the Trig Graphs and Limit worksheet. And I'm going to be teaching from the Resch Playroom. We got some American Girl dolls. We've been playing a lot of games. I like Rummikub and Sequence the best. But right now I got some Winnie the Pooh characters kind of looking in. So while I get this video set up, I need you to find that Trig Graph and Limit worksheet. All right, so that worksheet has 15 examples on it. We're going to do some examples as your notes, and then the rest is going to be your homework. Okay, so we're going to start out with number 1. The limit as x approaches pi from the right of cotangent of x. Remember that little plus sign there means we're going to approach it from the right. Okay, so the first thing we're going to do for all of these is we're going to graph the trig function, which is a bit of a review. We're going to give it a go here. Okay, so when I graph cotangent, remember that cotangent is really the cosine x over the sine x. So what we're really going to do is we're going to graph where sine of x is. That way we know where the asymptotes go. And we're just going to use our unit circle because there's no phase shift or period change going on here. So I'm going to start at 0, and I'm going to end at 2 pi. Cut that in half, cut that in half. So my 5 points are 0, pi halves, pi, 3 pi halves, and 2 pi. My amplitude is 1, so I'm going up to 1 and down to -1. When I graph the sine graph, we start at 0. I'm going to go up to 1, back down to 0, down to -1, and over to 2 pi. Now wherever my graph hits 0, that's where I'm going to put in the asymptotes. So I have an asymptote here at 0, I have one at pi, and I have one at 2 pi. So my cotangent graph, remember, is going to pass through those other points that haven't been used up yet. So we didn't use 3 pi halves, and we haven't used pi halves. But my graph looks like that. Okay, so now I'm interested in my graph as it approaches pi. So here's pi, and I want to be on the right-hand side. So this is me walking on that curve. As I walk on that curve and get closer and closer to pi, the limit, the y value, is going up to infinity. So my limit as x approaches pi on the right-hand side of cotangent. Here's me walking. As I get closer to pi, I'm going higher and higher and higher. So my answer is infinity. All right, so that's question 1. We're going to skip down to question 3 on your worksheet, and we're going to do the same idea for the limit of the secant of x. So again, know that the secant of x is really 1 over the cosine of x. So if I graph this, again, we have no period change or phase shift change. My amplitude is still up at 1 and down at -1. I'm going to start at 0, and I'm ending at 2 pi, and I'm putting all those same unit circle markings on here. This time, though, I'm going to graph cosine because that's going to help me figure out where those asymptotes go. So remember cosine. I put those. The asymptotes then are, in this case, are going to be at pi halves and 3 pi halves. But my secant graph, remember, are kind of a series of parabolas almost, they look like. So my graph is not the dotted line. I just use the dotted line to help me make my graph. It's the solid white lines as well as the dotted orange asymptotes that we have here. Okay, but now in this question, I am looking for the limit as x approaches pi halves, but from the left. Okay, so now I'm at pi halves. Get on the curve that's on the left-hand side of pi halves. So that would put me up here. As I'm walking closer and closer to pi halves, I'm going to be up higher and higher. So my limit is going to be infinity. All right, so now we're going to skip down to number 5. So number 5 is the limit as x approaches 3 pi halves of the tangent of x. Okay, so now if you look at this one isn't approaching anything. It's just approaching 3 pi halves. It's not from the left or from the right. So when I graph tangent, I'm going to graph that cosine first. Again, no phase shift, no period change. My amplitude is still up at 1 and down at -1. Okay, so I'm going to graph my 2 pi in all my unit circle pieces. And cosine same as the graph that's still on the board there. I have those asymptotes at pi halves and at 3 pi halves. But now it's a tangent graph. So at the points that I didn't put the asymptotes at, there's my tangent wave. Okay, so now I'm interested in what's happening at 3 pi halves. So at 3 pi halves, we have to look at it from the left. We have to look at it from the right. So if I put myself to the left on this curve, and I put myself on the right on this curve, well, this one I'm walking up, this one I'm walking down the closer I get to 3 pi halves. So am I ever going to meet up here? These two little guys here, one's going up, one's going down. They're never going to meet. So remember, if it's opposite, if they're approaching that point and they're not going to meet up anywhere, your answer has to be that does not exist. Again, if they were going to meet up at the same place, then it would be that value. But here, one's going up, one's going down, so opposite directions, so it does not exist. All right, the last one we are going to do together is number 14, so on the back page. So flip your worksheet over, and let's look at 14 here. So we got the limit as x approaches pi halves of the cosecant of 3x. All right, the first 3 that we did, the period was always 2 pi because there was nothing in front of the x. But now I have something in front of the x, so that's going to change the period. So my period has to be 2 pi divided by that 3. And also cosecant, I'm going to graph sine of 3x because that's going to let me know where the asymptotes go. All right, so if I graph this, there's no phase shift, so I know I'm starting at 0, and I know I'm now ending at 2 pi thirds. Okay, so now I got to be able to get all those other points on here. So my halfway point would be 0 plus 2 pi thirds divided by 2. So 2 pi thirds cut in half is 2 pi sixth. Okay, so if this is 0, this is 2 pi sixth. This is really 4 pi sixth reduced. So we can kind of fill in the pattern here. That's going to be 1 pi sixth. That is going to be 3 pi sixth. All right, I'm also going to graph sine here. So I'm going up to 1. Okay, so I have an asymptote then at 0, at 2 pi sixth, and at 2 pi thirds. So my graph are the orange asymptotes, and then this piece I just drew right here, and then this inverted piece down here. Okay, so now I want to know what is the limit as x approaches pi halves? So let's find pi halves first. Okay, pi halves is really 3 pi sixths here. So that means I'm going to be on the left-hand side, and I'm going to be on the right-hand side. Now, as I'm on the left-hand side and I'm walking towards 3 pi sixths, I end up right here at -1. When I'm on the right-hand side and I'm walking towards 3 pi sixths, I end up at -1. So my two people here, they're going to meet up. That meetup spot is that limit. So my limit in this case is -1. So on your worksheet, when you finish it for homework, you are going to have answers of actual numbers. You're going to have answers that could be a does not exist. And then you could have answers of infinity and negative infinity. Okay, at the bottom of the worksheet, we posted the answers, so you can take a look and check your work. If you have questions, let Mrs. Cook or myself know, and we'd be happy to help you guys out. All right, see you guys tomorrow. Bye-bye.